Hello everyone, my name is Dennis and you're on the Den Electro channel. Today we'll be making a power bank for a true radio amateur. As you might have guessed, the case is made from a multimeter. On the side, there's a single button made from a transistor for control. There are two USB ports for charging devices. The first is rated for 1 amp and the second for 2. To turn on the power bank, you need to hold down the side button. If you quickly double-click it, the flashlight on the other side turns on. When I turn the knob, a powerful flashlight turns on. Well, I'll tell you how to make such a power bank now. To make it, you'll need a burned-out multimeter, a circuit board for homemade power banks, which I reviewed in the previous video, and a battery. I'll be using a 10,000 mAh lithium polymer battery. That's enough to charge my phone 3 times. The battery, although not new, still works perfectly. First, I open the tester and remove all the internals. The back cover is full of bumps and dents. They need to be removed to level the surface. Then I glue the cardboard with double-sided tape. This is all done to smooth the surface. I place the battery there and press it firmly. Now, even if the power bank wobbles a lot, the battery won't move. There are 2 posts on the front panel near the display window. The board can be inserted between them very comfortably. But the board turned out to be a bit wider, so I need to adjust some things. There's a rectangular notch on the board. I snip off the corners and make a larger cutout. Now the board will fit into the case between the 2 posts and stay there like a glove. And a shelf will support it underneath. Now I need to place the display under the board. Keeping the board level, I need to figure out where to make the cutouts for the connectors, light bulb, and buttons. If necessary, do the same on the back panel. After some diligent file work, it turned out I'd gone a bit overboard. I ended up with a large gap near the USB port. To make the flashlight, you'll need a shift wheel, a 1N4007 diode, and 10.5 mm white LEDs. I make holes in the wheel with a heated paper clip. Of course, the melted plastic around the edges of the hole needs to be removed, otherwise the LEDs won't fit evenly. Once the LEDs are installed, you'll get this pretty little thing. On the back side, all the LEDs are soldered in parallel, wires are connected to them. All soldering should be made as thin as possible so they don't catch on the board later. The board needs to be trimmed so it's even and doesn't protrude. Now let's look at the back side of the board. There are many contacts on it. We need to find contacts that will close when the wheel rotates. I'll use these 2 contacts. They will close via the plates mounted on the wheel. The transition from one side of the board to the other occurs through small holes. After that, we need to solder the wires to the required contacts here. Then, break off a piece of the wall in the front cover, as shown in the video, and insert the wheel. We lay the wires in the place where the wall was broken. The wires should be thin and soft. When the controller rotates, they shouldn't create any resistance. Then I put the board back and tighten the screws. Now you can spin the wheel, but not 360 degrees, only to the point where the contact's close to turn on the LEDs. Note that I filed the board down, so that I can easily install the display later. Just in case, test the wires soldered to the board. There should be infinite resistance between them. If not, the LEDs will draw current even if they're turned off. It turned out that my resistance was about 900 ohms. The current flows through the remaining electronic components on the board. For clarity, let's look at the diagram. The on/off button is a contact on the multimeter board that closes when the dial rotates. When the switch is open, no current should flow through the LEDs. But some components with a 900 ohm resistance were soldered parallel to the button. In this case, the LEDs will not light, but a small current will flow through them, and the battery will eventually discharge, albeit over a very long period of time. Then I unsoldered everything unnecessary and measured the resistance again. Everything showed infinite resistance. I taped over the extra slot. You'll see later what this is for. Next, you need to make a window on the multimeter display for the power bank display. First, you need to remove the white reflective foil and then the polarizing layer. Otherwise, the image will be dark. Now I lay the display down. I place a conductive rubber band on it to support the board from below. And then I lay the board on top. Then I connected all the wires. The white wire will be soldered to the positive terminal of the battery, the negative terminal to the black wire. The positive terminal will go through a diode to the LEDs mounted on the regulator. Then he will leave them and go to the board. And then it will pass through the open contacts on the board. From there, it will exit and connect to the negative terminal. To make a button, you need to take either a transistor or a microchip in a similar case and bend the pins as shown in mine. Apply a drop of hot glue to its surface. The transistor will be inserted into the case like this. It will be held in place by its flange at the bottom, and its pins will hold it to the top cover. To secure the board more securely, I applied sealant. I glued several layers of tape to this board to prevent sharp parts from piercing the battery. I also soldered the positive and negative wires to the battery terminals. Since both halves of the case now have no fasteners, I had to glue them together with superglue. By the way, I also filled the extra window under the USB ports with sealant. Then, after assembly, I noticed a problem. The display should show 3 digits. The first is a 1. It was hidden by the multimeter display. This happened because when I applied the power bank's board, it was always partially charged, and only 2 numbers were displayed. After all this work, you'll have a super mega original power bank that you won't see anywhere else. That's all for today. Like, leave a comment, and don't forget to subscribe to the channel if you're new here, and bye everyone.